Hi, I'm John Kraus. I'm the captain of XC Johnson. I've been working here at Lamy for 12 years, and I'm here to talk about the physics of sailing.
At the Los Angeles Maritime Institute, we have 4 vessels, the schooners American Pride and Swift of Ipswich, as well as the twin brigantines XC Johnson and Irving Johnson, which we will be discussing in this video.
We have a few different types of sails. We have sails that run fore and aft, lengthwise of the boat, and we have square sails on the foremast which go across the ship or athwartwards of the ship. You can maneuver those according to the direction of the wind to drive the boat where you want it to go and not necessarily where the wind wants it to go.
Bernoulli's principle explains how pressure and velocity are related. Acceleration causes lower pressure. As a force, in this case wind, pushes on the sail, lift is acting perpendicular to the flow, and drag is acting in the same direction as the flow. In order for the sails to push the boat forward, the center of effort needs to be in the front of the sail. This is achieved initially by the cut and shape of the sail, and can be adjusted by changing the trim or angle of the sail as it is hit by the force.
All sailboats and all sails have a shape in it, like a belly. All right, and that's intentional. They're not just flat boards, and when you sew it, it has to represent that curve, and that's again to take advantage of the Bernoulli's principle, which makes the wind go faster around the outside of the sail. So one side has to be bellied out so that it has longer to travel than the inside. Where that sail is pulled to relative to the wind is going to have a great effect on how that sail drives the boat. And you would think that, say if the wind is coming off your starboard side and you have a big sail above your head that's billowed out, to your left, you would think you'd feel more wind on the starboard side, but in fact, if you just go to the port side, you'll feel all this wind rushing by the sail, and it's counterintuitive, but you'd feel more wind on the opposite side of the sail than the wind is coming from if your sail's trimmed right. A lot of people look at a sail and they'll see the wind hitting it, and they think that translates to the drive of the boat, and that is true in many cases. Usually true for square sails, for instance. It's a lot of just pushing on the boat. But those fore and aft sails aren't really doing the same kind of pushing, so those fore and aft sails are using the same principle that airplanes use to fly, lift. So what happens is they get a shape at the front of the sail that allows the wind to rush faster over the outside of the sail and slower on the inside, creating a lower pressure on the front, higher pressure in the back. So it's actually like a suction. It's a vacuum on the front of it. So it's actually more like it's being pulled forward in that circumstance. You can move the clew of the sail, the corner of the sail, too far in, and suddenly you're going to end up with a hook on the end of your sail, and that's going to be resistance. All right, it's just like going through the air with your hand out the window. You can feel, if you're in your car and you put your hand out the window, you can feel the wind pushing on it. Well, the same thing's going to happen when you have the sail trimmed in too much. Corner of the sail is going to come in and be more act like resistance and slow you down. So with the square sails and those fore and aft sails, you kind of have both forces that can work together and create a lot of force to drive the boat. A lot of people would think that boat can go the fastest if it's just running with the wind, going straight downwind, as we say. And there was a Newtonian law that helps push the boat.
Newton's laws of motion state that 1. A body at rest will stay at rest until enacted on by a larger force. 2. The force acting on an object is equal to the mass of that object times its acceleration. 3. For every action, there is an equal and opposite reaction.
For instance, the modern sailboat that just has a jib and a mainsail, even if you adjust the sail to catch as much wind, you're not going to get the same drive out of the sail area that you would if the wind was coming from one of the sides off the beam. So the more sail area you have to drive the boat with wind, the faster you're going to go. And that's a brief introduction on sail theory. We'd love to teach you more. If you want to come sailing with us, if you're interested in that, go to our website, lamytopsail.org.